Okay, this video is going to be on graphing limacons. I'm going to do ones with inner loops and then ones without inner loops. So they're honestly pretty simple. I'll go through the steps based off of how I'm doing the examples. So let's start with, let's graph r is equal to 1 plus 2 cosine of theta. Okay, so in order for there to be an inner loop, a, which is this value, and b, which is this value, a must be less than b. 1 is less than 2, so there is an inner loop. Now we need to know where its point, like in the direction it's opening, how long it is, and the tip of it, right? So because there's plus 2 cosine, that's going to be opening to the right. So how do we find this? Well, let's find the max values, right? So let's plug in +1 and then -1 in substitution for cosine. So r is equal to 2 times 1 is equal to 2. R is equal to 2 times -1, which is equal to -2. So that means whoa, what the heck did I just do? Completely disregarded the equation. R is equal to 1 plus 2 times 1 is equal to 3. R is equal to 1 plus 2 times -1, which is equal to -1. So the outer loop has the tip at 3, and then the inner loop, you take the negative value, the lowest value, and you take the opposite of that value. So because it's -1, that means it's opening to the right. So that means the inner loop is going to have a distance of 1. Okay, so now that we have that, the next step is to find the zeros. So let's set equal to 0, 1 plus 2 cosine of theta equals 0. Cosine of theta equals -1/2. So that's at 2 different instances, right? That is at 2 pi over 3 and 4 pi over 3. Let me zoom in a little bit. It's really small. Okay. Okay. Next, let's evaluate r at the values that we like. We like 0, pi over 2, pi, 3 pi over 2. So 1 plus 2 cosine of 0 is 2. So we have 1 plus 2 cosine is 3. So we have 3 comes 0. Pi over 2, we have 1 pi over 2. At pi, we have -1 pi. And then at 3 pi over 2, we have 1 3 pi over 2. Um, so now we can graph this. So there's a point at the outer loop, 3 comma 0, right here. 1 pi over 2, so that's the top of that little inner loop. And then negative 1 pi, we can take the magnitude 1, and then pi plus pi is 2 pi, so that's going to be this direction, 1, so right here. Or you could just get the absolute value of 1, or you just flip this, right, which is what I just did here. There's negative 1 pi is right here, but we flipped it. And then 1, 3 pi over 2 is here. So now how do we draw this? I think let me draw this point a little bit more right here. And right here. So it's going to be kind of like this is the Jesus Christ, that looks terrible. So anyways, this is at point 1. This is at 1. That's at 3. Alright, let's do another one. Let's graph r is equal to 2 plus 4 sine theta. So when sine is positive 1, we have r is equal to 5. So the outer loop is going to end at 5. 6, I mean. When it's negative 1, we'll have negative 2. So the inner loop is going to be upwards, kind of like this, etc. It's going to have a total height of 2. Okay. So now, let's solve for zeros. We have 2 plus 4 sine theta. Sine theta equals negative half. So that is at pi over 6. And pi over 6. That doesn't really matter. All we need to do now is just plug in pi, 0 pi over 2 pi, 3 pi over 2. So 0, we're going to have 2 plus 4 sine of 0, so that's going to be 2 comma 0. A pi sorry, when you plug in 0, no, that's right, yeah. When you plug in pi over 2, you're going to have 6 pi over 2, and then for pi, you're going to have 2 pi, and then for 3 pi over 2, you're going to have negative 2, 3 pi over 2. Remember that this is a negative, so we're going to have to change. So basically flip it 180 degrees. So now we have to graph that. So we have 2 comma 0, 6 pi over 2, so that's way up here. 2 comma pi, and negative 2, 3 pi over 2. We're going to switch that up to here. And it's going to it's always hard to figure out how to draw. Okay, that's definitely not right. Actually, it's not that that's wrong, it's just, okay, so those the origin. There we go. Perfect. So that's going to have a height of 2, 2, 6. Okay. Now let's go for ones that have no loops. Namely, when A is greater than B instead. So let's graph R is equal to 3 plus 2 cosine of theta. So let's plug in when cosine is 1. We have 5. And then when it's negative 1, we have 1. Okay. So now let's solve for 0, see if it touches the x at the origin. 3 plus 2 cosine of theta equals 0. Cosine of theta cannot be less than 1 or greater than 1, so there's no solution for that. So it doesn't touch the origin. So now let's plug in the points 0, pi, pi over 2, 3 pi over 2. 0, pi over 2, pi, 3 pi over 2. So at 0, we have 5. We have 5, 0. At pi over 2, we have 3. At pi, we have 1. At 3 pi over 2, we have 3. So we know it's going to be opening up. But, okay, so let's graph this. Okay, something to note though, does it have a dimple? So a dimple occurs if 1 is less than a over b is less than 2. So we have 3 over 2. 3 over 2 is greater than 1, but it's not greater than 2. So there is a dimple. And it occurs at the minimum. So let's draw this. So we have 5 comma 0, 3 pi over 2, 1 pi, 3 pi over 2, so man, these are always hard to draw. So that is at 5, that is at 3, negative. Okay. Let's do another one without an inner loop. Let's graph r is equal to 4 plus 2 sine of beta. So it's going to be opening upwards. And 1 is greater than, 1 is less than 4 over 2, but 4 over 2 is not less than 2, it is equal to 2, so there is no temple. So let's plug in when sine is beta 1. So we have 4 plus 2 is 6. So that's at 6. And then negative 1, we have 2. Now let's plug in 0 pi over 2 pi, 3 pi over 2. So at sine of 0, we have 4 pi over 2, we have 6 pi over 2. And then we have at pi, we have 4 pi. And then we have at 3 pi over 2, we have 2 3 pi over 2. Alright, so now we can graph this. So we have 4 comma 0, step right here, 6 pi over 2, way up here, 4 pi, here, and 2 of 3 pi over 2 is right here. It kind of looks like an egg. And that'll be all for this video.